Hi, I'm Jeremy, and I'll be telling you about ideal gas law. This law will not come out with the same results as will an experiment in the lab. This law works with imaginary elements that behave ideally under standard temperature and pressure, whereas the ones that we use in the lab will not. This law does have a few consequences. If temperature and pressure are kept constant, then the volume of the gas is directly proportional to the number of molecules of gas. If the temperature and volume remain constant, then the pressure of the gas changes is directly proportional to the number of molecules of gas present. A few more are, if the number of gas molecules and the temperature remain constant, then the pressure is inversely proportional to the volume. If the temperature changes and the number of gas molecules are kept constant, then the pressure or volume, or both, will change in direct proportion to the temperature. The formula for ideal gas law is PV equals nRT, where P is equal to pressure in atmospheres, V is equal to volume in liters, N is equal to the number of moles, R is equal to the ideal gas constant, which is 0.0821 liters atmosphere per Kelvin mole, and T is equal to temperature in kelvins. And here is an example of how to use this law.
If I have 4 moles of gas at a pressure of 5.6 atmospheres, a volume of 12 liters, what is the temperature? Well, they're just basically just laying this one out for us, to solve easily here. If I know the formula, same if I was doing a combined gas law problem, I'm going to go through first. Personally, I'm going to go through first and identify what's what. That's what I like to do. Okay, and you can make a list, or you can just go and write it right over the top of them, like I'm going to do here. This 4 moles, that's going to be what? N. 5.6 atmospheres is P. A volume of 12 liters is V. I'm trying to find temperature, which is T. And they don't have to give me R because I already know what R is, right? Let's go ahead and rearrange this formula to solve for T. To solve for T, I got to divide by NR, right?
Okay.
So, T equals PV over NR. P, 5.6. By all means, keep your units on them. I just, limited space, so I'm saving where I can. N, 4 moles. R is what? 0.0821. So now it's just a matter of getting your calculator, doing 5.6 times 12 divided by 4 divided by 0.0821. And we won't worry about significant figures. I'll just call it 205. What's my units on that? Is that what you got?